All right, this lesson shows how to simplify rational expressions. So first of all, a rational expression is a polynomial divided by a polynomial. We call that a rational expression. And so the way that we simplify a rational expression is by eliminating common factors. Like a numerical fraction, a rational expression is undefined when the denominator is 0. These undefined values of the variable are called excluded values. And so that's just simply saying, give me 1 second here. If you have a fraction of 3 over 0, remember that's undefined. So you can't divide by 0. So when we simplify this, any values of the variable that would cause the denominator to be 0, we have to name those as excluded values. And you'll see what I mean as we do this. All right, so let's start with a few simple ones here. We're going to simplify these and state any excluded values. Okay, so the first thing you want to do is look for things that you can factor. So in the denominator of this, I can divide a 5 out of this. And so I can simplify this to x minus 1 over 5 times x minus 1. So I took 5x minus 5 and I factored out of 5. That gave me 5 times x minus 1. Well, x minus 1 over x minus 1 is 1. So these cancel each other out. And so this whole thing simplifies to 1/5. And a lot of times my students will say, well, where did the 1 come from? Well, x minus 1 divided by x minus 1 is 1. So you can think of it that way. All right, so this whole expression here, this rational expression, is the same thing as just 1/5. And so that's the purpose of simplifying them, is because a lot of times you can make it a whole lot easier. All right, so let's look at this one. All right, well, you can't factor anything here, so we don't have addition or subtraction. But I can simplify. So 21 divided by 7 is 3, and a to the second divided by a to the third is a to the negative first. And remember, don't leave your answer with negative exponents. So I'm going to rewrite this as 3 over a. Now, if I was doing this problem myself, I would not have written this, because the way, so where this came from is the power rule, where you have a power divided by power, and they have the same base. You subtract the exponents. So 2 minus 3 is negative 1. But the way I would think of it is there's 2 a's in the numerator and 3 a's in the denominator. So the 2 a's in the numerator will cancel out 2 of the ones in the denominator and just leave you with 1 a in the denominator. Okay? So let's look. What can we factor out of this? Well, I know I can factor a c out of the numerator. 26, the factors are about 13 and 2. Oh, and 13 is a factor of 91. 13 times 7 is 91. So I can divide out a 13c in the numerator. And so 26c cubed divided by 13c would leave me 2c squared plus 91c divided by 13c is 7. And in the denominator, notice what's down here. There's a 2c squared plus 7. Those will cancel out, and I'm left with just 13c. All right, so let's look at some other examples here. Okay, so my numerator here, I can factor out a 3. So that would give me 3 times x minus 2. The denominator, okay, well, I've got a trinomial. So are there 2 numbers that multiply to negative 6 and add to positive 1? Well, that would be positive 3 and negative 2. So that factors to x plus 3 times x minus 2. So now the x minus 2's will cancel each other out. And I'm left with 3 divided by x plus 3. All right, let's look at this next one. Okay, I can factor a 6 out of the numerator. So it gives me 6 times x plus 2. For the denominator, this is a trinomial with a coefficient on the x squared. So I'm going to do slip and slide on this. And so if you're not familiar with that, I have a lesson on that. You can go back and watch. So let me do that. I'll do it right down here. So I have 2x squared plus 7x plus 6. And so the way slip and slide works is you take the a value times the c value. So then I have x squared plus 7x plus 12. Looking for two numbers that multiply to 12 and add to 7. That would be 4 and 3. So I have x plus 4 times x plus 3. All right. And then once you get to that, here's the slide part. You got to slide this a value back down here. Divide those factors by that. All right, 4 over 2 simplifies to 2, so that's x plus 2. This one can't simplify anymore, so you slide this 2 up next to the x and get 2x plus 3. All right, so that's what that factors to. So I have x plus 2 times 2x plus 3. All right, so those will cancel each other out. Leaves me with 6 over 2x plus 3. All right. All right, so I just realized I've been forgetting to state the exclusions. So let's go back to this previous slide. And so if you look at this, this factors to x minus 1. So if x was 1, then you would end up with 0 here. And so x cannot be equal to 1. That would be an exclusion. So if I plugged in a 1 here, I'd have 1 minus 1 is 0. 5 times 0 is 0. 0 in the denominator is undefined. So what you would say x cannot be equal to 0. Sorry, I forgot to put these. I just realized it. On this one, so a just can't be equal to 0. All right, because if you put 0 down there, then you would have 0 in the denominator, and that would be undefined. All right, on this one here, I just realized up here I said it right, x can't be 1, but then I wrote x can't be equal to 0. So let me fix that real quick. So x cannot be equal to 1. Now down here, since there's nothing in the denominator, there are no exclusions. Okay, so let's go back to this one. So in this one, let me do this top one first. X can't be equal to negative 3. And x can't be equal to 2. Because both of those would give you a negative exponent. I mean, what the heck am I talking about? Both of those would give you a 0 in the denominator. All right, so on this one, x can't be equal to negative 2. And on this, so what can x not be here? So the way you can find out is just say 2x plus 3 equals 0. What would cause that to be 0? So subtract 3, and you get 2x equals negative 3. Give myself a little more room here. Divide by 2. And so x equals negative 3 halves would cause it to be 0. So another one it can't be is x can't be equal to negative 3 halves. Those are the two exclusions. All right, sorry I forgot about those earlier. So once you factor it, Make sure you check for the variables that would cause the denominator to be 0, and then you list those as exclusions. All right, I think this is the last piece. So recognizing opposite factors. So notice that x minus 3 is the opposite of 3 minus x. Well, when you notice that occurring, what you can do is factor out a negative 1. So factor out a negative 1. And so what that's going to do, and I'll factor it out of the numerator. You actually could factor it out of either one. I'll take it out of the numerator. So negative 1, that would become negative x plus 3, right? So if you divide x by negative 1, you get negative x. Minus 3 by negative 1, you get plus 3. Over 3 minus x. And notice that negative x plus 3 is the same thing as 3 minus x. So I'll just rewrite this to show you that. So I have negative 1 times 3 minus x, if I just switch the order of those, over 3 minus x. And so those will cancel out, and this simplifies to negative 1. And the exclusion would be that x can't equal 3, because 3 minus 3 would give you 0 here. All right, so let's look at this next one. 4 minus x squared. All right, well, hopefully you recognize that as a difference of squares. And so that factors to 2 plus x times 2 minus x. That's called a difference of squares. In the denominator, I can factor out a 7. So 7 times x minus 2. So I have x minus 2 and 2 minus x. So those are opposites of each other. So I'm just going to divide a negative 1 out of that one. So that's going to give me negative 1 times negative 2 plus x. Again, I'm factoring it out of this second factor here. Times 2 plus x. So I'm going to leave that one alone. Over 7 times x minus 2. So my exclusion is going to be that x can't be equal to 2, because that would cause this to be 0. Let's rewrite. Oops, giving myself room here. Let's rewrite negative 2 plus x as x minus 2. So we have negative 1 times x minus 2 times 2 plus x, all over 7 times x minus 2. Those will cancel each other out. And what I'm left with is negative 2 plus x over 7. All right, let's look at this next one. So a lot of times my students would say, well, there you go, there's another difference of squares there. Well, no, because this variable is not squared. And the square root of 3, that's not a perfect square. So what we're going to do with the numerator is divide a 3 out and make this 1 minus 3d. And then the denominator, all right, this is a slip and slide here. So get a different color here. Remember, slip and slide, we're going to multiply 6. Well, let me just rewrite it here. 6d squared plus d minus 1. So I'm going to multiply the a times the c. So that gives me d squared plus d minus 6. Two numbers that multiply to negative 6 and add to positive 1. So it will be positive 3 and negative 2. So d plus 3 times d minus 2. Now I have to bring that 6 back down, bring it back in. So 6. And so this is going to simplify to 1/2. The 2 is going to come up next to the d. So I'm kind of skipping a step here. Hopefully you're following this. So that'd be 2d plus 1. So that's simplified to 1/2. I left the 1. I brought the 2 up here. This would simplify to 1/3. So I'm going to leave the 1 and bring the 3 up next to the d. So 3D minus 1. So that goes down here. 2D plus 1 times 3D minus 1. All right, so we can look for our exclusions here. Let me switch back to this color. So for the exclusions, you would have 2D plus 1 equals 0, because we don't want that to be 0. So subtract 1. So 2D equals negative 1. So one exclusion is D equals negative 1/2. So I'm just going to go ahead and write that over here before I forget. D can't equal negative 1/2. And the other exclusion would be 3D minus 1 equals 0. So 3D equals positive 1. Sorry, divide by 3. And D equals 1/3 would be the other exclusion. So D equals 1/3. All right, so we have 1 minus 3D and 3D minus 1. Those are opposites of each other. So let's factor a negative 1 out of the top one. So that's going to end up with negative 1 times 3. So that's just going to become negative 3 times negative 1 plus 3D over 2D plus 1 times 3D minus 1. Go ahead and rewrite this as negative 3 times 3D minus 1. I'm just changing the order. Over 2D plus 1 times 3D minus 1. These will cancel each other out. And so I'm left with negative 3 over 2D plus 1. Another question I get asked is whether or not you need to leave those parentheses around the 2D plus 1, and the answer is no. You don't need to leave those there. All right, I think that's it. Let's check. Yep, that's it. So that's simplifying rational expressions. It's not the easiest topic in the world. It's a pretty challenging topic. So just practice, and hopefully it'll start to click. All right, so give it a like and a subscribe if it was helpful to you, and feel free to leave me a comment. Until next time.